Um, as he says, it's probably more of a what not to do than a guideline, shall we say. But yes, what I'd like to talk about and go through is building. So there's a couple of interesting points. Building AI on the cloud for Deloitte. So you've got AI, and that is the buzzword of the month, I believe. The cloud, which was the buzzword of the month at some point, and Deloitte, which probably wasn't a buzzword in the last 60 years. But maybe. Who knows? But, I mean, come on, it's full of buzzwords. But the point is, what we're trying to do is build advanced algorithms on the cloud using horrifically large amounts of data and some really good tech to help clients. And that's sort of what we're about. And we really care about the algorithms, but to really get algorithms going, you have to care about the tech as well. So we have an AI team. We're a bunch of data scientists, a bunch of technologists, a bunch of engineers and solution designers who really care about just getting stuff done and getting algorithms deployed. So we'll just go through some key principles and what we perceive as AI. I mean, you can make it up as you go along, really. Then development, production, deployment, some enterprise solutions. One of the key things I'll talk about is, okay, I've trained the scikit-learn model, but where does that go in reality? How do we use it and what's it do? And then the future of AI on the cloud. I think the AI is definitely something that we should start farming off to computers we don't own, because it gets very expensive. So yeah, I did my background in high-energy physics. Again, it's basically the same thing, writing production software for high-frequency systems and then running jobs on remote clusters in universities across the globe. So it really was like AI on the cloud, just in science. So then I moved to Deloitte, and then been doing the same thing just in financial services. So there's another overlay here, which is FS is a very regulated sector. So it's fun, but fun with caveats that if you do it wrong, you might get put in prison. So yeah, we have to or fined quite a lot. So you have to take this with a pinch of salt as to how much you can actually do. And when you say, someone's released a new package, I'd like to include that, and include that. Then someone goes, how do you know it works? You're like, well, there's varying degrees of open source adoption in the FX sector. So yeah, what we did is you can't build your platform. Clients have varying degrees of maturity. Some of them love the cloud. Some of them would rather not be anywhere near the cloud. So what we did is built our own platform for innovation. So we just were like, right, we need to stand up a piece of cloud software. We need to get the data. We need to get the algorithm. We just need to try everything out ourselves such that we have the experience to go and deploy it. So this is all about how do you take everything that is location, open, dark data is let's not talk about that. But then really like audio, video, how do you start building solutions that combine multiple different types of data all in one go? And that's where it gets a bit more complicated. We do love Amazon slightly. It's really useful. Azure less so. GCP are quite good as well, but I realize I'm in front of AWS user group, so we do love Amazon. Realistically, the power of the AWS console allows you to build a lot of stuff quite quickly. And in terms of prototyping and rapid deployment, we found that to be very useful. And certainly all our solutions are there. When we are done, you can talk to me about Azure to AWS migration, possibly in the pub, unofficially. Then databases, again, pick some NoSQL databases, pick some interesting tech. Nothing too exciting in languages, but then realistically, what happens, right? So what do you want to get out of it? So it's all about customers, it's about computer vision, it's about IoT sensors, it's about sort of FS product development. So the actual solutions are really where mostly people will pay you. So people don't pay you for half an algorithm that might work on your computer, as Abby said. people will pay you for something that gets deployed in the cloud and will work in reality and won't fall over. So this is where we're going to. So that's the last good slide. My terrible, terrible excuse is I've been dealing with a production incident all day. Yeah, I'd like some sleep, please. But yeah, so AI, data. You need some data. You have to have some data, and if you don't have data, there's no chance of training any algorithms. So again, my favorite is garbage in, garbage out. You need to get proper data, you need to do it, you need to clean it, and you need to use it properly. So again, multiple formats. What happens if you start mixing images with maps, with a CSV you found on someone's internal network plus an SQL database everyone has forgotten about for 5 years? Right? This is where the interesting product development can happen, because people want to innovate and move beyond what their legacy systems are. But again, legacy systems are there firstly for a reason, and were also designed 40 years ago. So we have to bring all these sources together and transform them in such a way that it's usable. So firstly, there's ETL, and managing your ETL I'll go into later, but realistically, that's how do you build effective workflow management. And then NoSQL, that was a buzzword. I think it still is. But anyway, for a data scientist, it's really the best way to be able to see everything. You don't care about views, and you don't care about, but I think these business users need 5 fields. As a data scientist, you want everything, and you want it now. So realistically, NoSQL, present everything in a completely denormalized fashion, all the data fields, and then we found the best way is just let the data scientists do whatever they want, and then come back and go, hang on, let's separate that into an ETL process, and you can't do that. So yeah, we just stuff it on S3. This is our backend storage. And then Elasticsearch and Mongo are really, really good. Use both of them, different purposes. Not quite the purposes they're intended for, but we like pushing the boundaries, especially in terms of Elasticsearch and geospatial search. So Elasticsearch has some really good geo capabilities. I probably need to fix a few things, but yeah, they're really, really good. So yeah, this is sort of the key technologies, but the thing I want to get across is once you get beyond CSVs, data is not easy. Once you get out of a Teradata warehouse or an Oracle database, your ETL gets a lot harder, and this is where if you put the effort, if you put the tech in here, you just get better. It's just easier to do data science. So what is AI and what is data science, right? So AI is basically, for us, it's algorithms inside a human useful case. So how do you build sufficiently complex algorithms and ensembles of algorithms? So mix in some vision, mix in some word processing, mix in some regular classification, all this sort of stuff. How do you put that into a product that a human can use? So yeah, algorithm design. If you have a couple of days of design workshops, your entire project, your entire 6-week or 6-month project will get a lot easier. And it's just thinking through what you want to do. And humans are still greater than computers at this. So AI training AI, I think Google managed to do it. Facebook might have done it. But realistically, if you just think about what you want to do for 5 seconds, it's good. And labeled data, as hopefully every data scientist will know, you need something to train. And you need something to train where you know the answer. So this is where, again, Mechanical Turk, all these crowdsourcing options are quite useful. But at the same time, occasionally you do have to label things yourself, which might take a bit of time. But then once you get there, once you actually try and do it, you have this entire workflow. So you end up going around in circles, and the life cycle of project is just when you get fed up of going around in circles. So design, dev, training, reporting, this is all fairly standard stuff in terms of what your work will be. But again, if you can do this on the cloud, if you can share this, and if you can have the consistent development environment that again, Abby was talking about, I mean, this was completely right in terms of if you'll get your data scientist to sit inside a container that then is identical to the environment they deploy in production, you will suddenly lose all these I'm using Pandas version X and I'm using Pandas version Y problems. If they want to integrate a new library, you get it into the dev container, you test it in the test container. It's really, we've certainly moved on from Python virtual environments and from our package lists into Docker containers with pretty much everything in dev, and then we strip it out for prod. So we do a process of, okay, this is your dev Docker, it's huge and you have every package in the universe. What's the 5 things you need for prod, and how do you deploy that without it falling over? So yeah, it's really like having that containerization, putting all your developers. Again, the other thing is training often has to happen in confidential environments. So you can't really train on your laptop. And I think the question about doing any development on your laptop, yes, you can develop on your laptop, but you can't do any, like, that's a very luxurious position where you're not dealing with any confidential data. For us, we live on remote servers, we live on remote VPCs, and we live inside sandboxed and firewalled environments. So you really have to, this is why the cloud is good, because you can put your security around it, you can put your roles, you can put your permissions, you can put your VPCs, but again, then you can say, okay, well, now I take this Docker image, and it has all the Python packages I wanted. So it's really how do you get that training environment in the secure system. So yeah, you can save everything. Again, S3, brilliant. You save everything, because the last thing you want to do is to go back 3 weeks and try and rerun an old model. And this is fine. Like, this is the bulk of your work, and this is really what you're going to have to do to get the results out. But then you have to think about where does your algorithm go? Where does your AI actually exist, and what does it do? Like, I can train algorithms till the cows come home, and I think I'd rather do that. But what does your algorithm actually do, and where does it interface with everyone else in real life? So yak shaving. Hands up, who's heard of this term? Yeah. Surprisingly, not as many people as I thought. But yeah, basically, it's this rabbit hole of infinite problems. And actually, one of the key things is that solving these problems is actually where, A, innovation and creativity happens, and B, you get more useful stuff out of this than you do out of the actual solutions you were doing. So a few of the things we developed, and just try and go through some of the reasons why we've developed interesting stuff for completely different problems. So one of our products is geospatial risk. So this is again a minefield. What do you define as risk, and what do you define as geospatial? But one of the big things is, how do you map out risk across a city, across an area? And one of the things we found we had to develop entirely of our own accord was routing algorithms. So there's a few on the internet. OSRM has one. Obviously, Google and a few others have their own commercial ones. But realistically, some of them do what you want, some of them don't. So in the midst of developing entire risk algorithm, we had to open up the box of point-to-point routing and do some fairly serious development on what's the best way to get a car or a person from A to B, and how does that affect your model. So that was one of the cool rabbit holes that we ended up solving a sensible problem for. Geolocation is fairly sensible, but what does it mean, and what the results you want to get out? This is where you start to see APIs as a on-demand database. So this is the other thing to think about, is once you're working in the cloud and you have access to a variety of different web APIs, because obviously you can do your sensible firewall filtering, you can download the stuff from the 3 APIs you want. You can start by constructing not only your own database, but external APIs as well. And you have this product which is not only built on your core data and your customer data and your key confidential stuff, but is also sourcing data from outside on demand. So geolocation was one of the things you can use. You can use a variety of different providers for this, but in the end, you have to provide the geolocation result that the client wants. And what they want for geolocation probably won't be what Google or anyone else will give you. And then the hardest one we found. Sorry. Yep. Insurance. So for the geospatial risk, it is primarily insurance. But again, any sort of commercial business who wants to understand where their buildings are located, where their people are going, where their assets are going, where their deliveries are going.
So what savings do the customer actually get from using AI over the existing models?
So that's a good question, because you assume there are existing models. No, I think there was a good question around, can we provide a particular profile or a particular set of information that's over and above what you already have? And that's an assessment we would do, and that's sort of the service. One of the service we would offer out of this product is firstly the assessment of, can we provide a better set of information for you? And then secondly, once you do that, can we integrate our risk engine, which is hosted on our AWS cloud platform? Can we integrate that with your core systems? So if your risk state is in a spreadsheet, how can we build the appropriate interface for you to update that? If your risk state is in a database, where do we build that solution? But at the core of it is this, and this is what I mean by AI. It's not about my routing algorithm. It's not about my classification model that goes into the midst of here. It's how do we package it up in a product that people can use. So yeah, hopefully that answers the question. And then the last one I want to go into is textures. So textures is it's for us a really difficult problem. If someone solved it, please talk to me. But one of the key things was textures is a data problem, i.e. how do you get labeled sets of textures that aren't taken under a specific image? So lots of textures data sets, like wall, material, etc., are taken in laboratory conditions and analyzed as such. But if you want to do textures in the wild, you want to look at a street or a satellite image, the textures are going to have clouds, they're going to have brightness. There's going to be all sorts of real-world context around this texture. And the second one is it's going to change from inner city, which is what you can see here, to the Midwest or to Cumbria, where, surprisingly, there's very little satellite imagery of Cumbria. It's really annoying, because it means I can't provide a complete algorithm across the same whole country. I have to train it for different places. So it's having this texture analysis in context. And we ended up, from the idea of let's build a satellite vision algorithm that can assess what's in the area. Like, ideally, the NSA have done this already, but they don't open source their software. Or GCHQ, we're on the UK. But the point is, okay, let's take some satellite maps and work out what's there, okay? So what happens if there's clouds? What happens if there's the satellite hasn't passed over for 5 years? How out of date are your information? This turns into a rabbit hole of how do you process images, how do you process textures, and how do you pick up the latest texture classification model that we spent a couple of weeks on. It's just how do you go down this rabbit hole of what does a pixel mean in the context of other pixels when all you're trying to do is like work out whether there's grass in Cumbria. You've got to balance it out. But this is data science, and then you try and package it up, and this is where I have to start apologizing for my architecture diagrams, because I think this is shocking. But anyway, API gateways, like this is the key to what we get up to. The point is, Web APIs in front of Beanstalk, yes, it's quite nice, but how do you scale it? Because the compute is not happening on Beanstalk. Unless you're going to have a whole load of P2 or C5 instances on your Beanstalk cluster, which there's some eyebrows going up here. But yeah, exactly. Like, you can't have it here. You need to pass off the entire AI workload into a backend. But what do you want to your backend? Do you want an EMR cluster? Do you want the ability to run Spark? Is Spark good enough for what you want? Does it have all the libraries? Then do you want to pass it off into AWS Batch and do this way? Or do you want to, SageMaker solves quite a lot of this. So as we go through our cloud adoption journey, and as we go through exploring the release of SageMaker that came out early this year, I still haven't got there yet. I think it'll solve most of these, but it'll probably have a few more. Then you come into workflow management. So what do you really want to do about your ETL dependencies? So do you want to do a bit of EMR at the start? How do you want to manage your ETL in terms of Luigi or Airflow, Azkaban, Uzi, and then step functions? Also really useful, but again, once you have to, a lot of this is working out where you want your compute to actually happen. Where do you want your GPU images? Where do you want your C5 images? Because you can only have so many of them, or you have a lot of money. But I mean, basically, you're either Bitcoin mining, you're a hedge fund, or you're a poor data scientist, basically. So GPU images are a rare resource. But again, like, how do you take this collection of technologies and use the right thing? So Azkaban, Uzi, do you want to do that? Versus Airflow, if you want to run some fine-grained stuff, versus stick it behind a API gateway. Do you want to put GraphQL just to merge up some APIs? There's a whole load of questions here, and there's no, as far as I understand it, please correct me if I'm wrong, there's no actual sensible answer to all of them. It's really which combination of these services is the right one to implement at the right time. And it gets complex, right? So, and this is really data engineering, is how do you understand the complete picture? And actually, this is my favorite topic at the moment, so please let's discuss this afterwards. Again, what does it look like in production? So you have a large data set, that's fine. I can train an algorithm, tick, 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 tick. This architecture diagram wasn't created by me, so it's all right. The integration with the wider system, so MVP, what do you call MVP? You need some customers, you need some public awareness of what you've trained, and how do you do it? And then really enterprise, forget about your algorithm. It's all about the monitoring, logging, operations, security, infrastructure roles, deployability, this sort of thing. So there is this journey of going from a proof of concept to an enterprise solution. What we found is quite a lot of customers want all of this around a POC. So there's a degree of, and again, AWS does actually make this quite easy with IAM roles and ability to set up everything, is you can hit a lot of these targets for a client while still going through the algorithm development on the way forwards. So it's kind of quite neat. As a data scientist, I hate the whole concept because it means I can't access bits of the database I might need to, or like arbitrary spin-up stuff. But then, yeah, data science is still a very cowboy field. I think at some point we need to learn, mature, and like accept our part in the whole development cycle. But so yeah, and then it comes down to what do you need to do this. So again, if you want to develop some algorithms, you need some data scientists. But that's not all you need, right? So data engineers is a very underrated field. You probably need about 2 data engineers to 1 data scientist at some point. But yeah, like ETL, complex AI integration with workflows, it's not a very common skill set. And understanding the entire cloud infrastructure and where you can do it is quite key. Data engineers sort of know how to set up databases, but they really don't want to be administrating them because they get bored every 5 seconds. So do need some database admins, because everything has to run at some point, and then everything has to run in the right environment, which is where DevOps turn up and tell us that we have to like containerize everything, and like, oh, it's terrible, but they do have a point. Like you do it, but the point is, all you're trying to do is run an algorithm with some data in the right environment. And the mix of these people depends on the project. Completely depends on the maturity, completely on the scale of complexity. So how you start your team, how you staff your engineering backend for an AI product is really, I mean, it just depends. But yeah, tendency is to not think about DevOps and infrastructure and database admins until it's too late. So I definitely try and start with one of each and then see how you get on. And yeah, that's it. So hyperparameter optimization, the future. Like AI will eventually self-train, but you need to do some work now. Then in terms of compute power, the question is how do we get all the cool chips that are coming out into AWS? There's a lot of work going on to releasing FPGAs on AWS. And there's the neurocomputing ASICs that are coming out. The future is really how do we get all these chips that are coming out that help everyone's lives, or at least data scientists' lives, go quicker. And then all these public data sets, data set integration, APIs, data is key. You can't have any algorithms without data. So yeah, I think, thank you, and hope that was useful.